Okay, so let's begin with a bit of an introduction here. My name is Rich Kleinman, and my goals with this planned podcast are first to prevent near-term human extinction, which sounds like something that a lot of people will find outrageous, and you know, I I expect that. Um, Another purpose is to document for posterity what people were thinking about in 2024. Um, I can imagine in the future, 20 years from now, the people who are inheriting the responsibility for digging their way out of the mess that the people are creating today are going to be angry, and they're going to want to know what people were thinking about when we were in the process of creating the mess. So I think this is partly to serve as a record for people in the future. So that's part of the intended audience is people who are going to be responsible for running the world going forward. Um, so I also one of the goals here is to stimulate a conversation about a topic which we don't have a lot of authentic conversation around. And we're talking about the topic of climate change. And a lot of people are, in my opinion, are paying lip service to this topic and glossing over it and uh, approaching it in a very superficial fashion. And what I wanted to do is promote and invite a more in-depth conversation. And the final goal, which I'll get to at the end of tonight's session, is to advocate a political path out of the mess that we're making. So, one of the issues we have is a lot of people recognize that we are making a mess and are taking a position that we're doomed. So we might call those people doomers. So I'm not a doomer, and I believe that it's there's a responsibility to try and articulate a path so that people can choose whether or not they want to do the work to try to save the future. So those are my goals. Um, as far as this story, right? This is a story which I think is compelling. I think, the people who really understand what's going on, we actually have a cliffhanger. There's a lot of suspense, and I think this should be an interesting story um, to that can be captivating. Are we going to collapse? How deep is the collapse going to be? What is the future? What might the future look like? So, um, so the the problem that we have here in a nutshell is you know human nature, our natural impulses are to always want more, right? We talk about in the newspaper, we talk about economic growth, and economic growth is a good thing. And what we're running into is a situation where we have a finite Earth. If you're to look at it, the Earth is like a petri dish full of nutrients for bacteria to grow in. That we can only expand as far as the contents of the petri dish allow us. And one of the things we're running into here is we have a finite planet, and we're running into the boundaries of planetary habitability. So that's kind of the big, in the nutshell. Um, so are we, big question is this cliffhanger is, are we going to make it or not? And I would say that if I were to answer that question as a betting man, I would probably say that we're not going to make it as a betting man. Now, but I don't know that. And given that I have children, I'm going to fight for us to make it. And to me, it doesn't necessarily matter whether we're going to make it or not in terms of dictating what actions I might take in my life, because I have children. So I'm a character in the story, and my character is a dad. And as my character wants, biologically is an imperative for me to try and protect my children. So that's a basic biological impulse. So the people here in the audience with me, you guys are the age of my kids. So you are archetypes of people I want to protect. So one of the things I want to do now, which may seem counterintuitive, is I do want to talk about another character, and that's to talk about God and creation. And talking about climate change, and it may seem counterintuitive to want to talk about God, but when we think about the story of people human beings, God is arguably the most important character in terms of our relationship to God. We all have, society is architected around interpretations of God. And, it would be, I think, naive to try to tackle this problem without addressing the various interpretations of God. And, one of the reasons that we are divided and unable to deal with this problem is we live in a world with so many different interpretations of God. So I want to introduce God as a character in this drama. So one of the problems is, and let's acknowledge that our interpretations of God are used to rationalize our behavior. And so one of the issues with our interpretation of God is many of the interpretations of God that we're working with arose in the past. And in the past, we didn't have as much information as we do today. So that may have led to interpretations of God which are different had we begun our interpretation of God now. So, for example, if we look at the Bible, the Jewish Bible, maybe the Torah is like 5,000 years old. The Christian Bible is 2,000 years old. The discovery of DNA, which reveals a lot of the story of life on Earth, was not discovered until 1953. So we have a lot more information now, which points to a different interpretation of God than was arrived at 2,000 years ago. So let's see. So let's talk about what, I'm going to share my interpretation of God, and I can maybe just write this down, is that God is synonymous with the universe and creation and truth. Okay, so this is a perspective of God, which is might be called pantheism, and pantheism was a philosophy from the Spanish philosopher Spinoza, and later Einstein agreed with Spinoza's perspective of God, which is something that's different than God being a personality, God being in man's image. So, what we know now about the universe is now we have telescopes, we have the ability to measure the speed of light, and with these telescopes, we can recreate a universe that began 13.8 billion years ago with an explosion called the Big Bang. So humility teaches us that we don't know, what caused the Big Bang. So, one of the things I want to do is begin with a sense of humility and mystery, to say, I don't know, and I don't think I'll ever know what force caused the universe to begin. It doesn't, scientifically, there's no logic to the beginning of time, matter, and energy. So there's something out there that we don't understand. And, for me, God is the word that describes creation and nature. Okay, so 13.8 billion years ago, from nothing, something shows up. And almost 10 billion years go by. The first 2/3 of the history of the universe, there's no Earth. So 4.5 billion years ago, out of this, this explosion of the Big Bang, this expanding universe, some of the, the material from that, ancient explosion coalesces and cools and becomes our solar system, the sun and the planets, the Earth. So what we can understand now, which is different than, say, 2,000 years ago when the Bible was written, is the Earth is not the center of the universe, and humans weren't present at the beginning of the universe. So here we are on, so this Earth is created, and then very shortly after the Earth is created, biological life begins. So we have a question whether the Earth was born alive or whether life began after. And then there's a question: how do we define life? The Earth was chemically reactive. The biological life came shortly after the Earth began, and this language of life, DNA, appeared pretty quickly, and so chemical reactions, were happening at the very beginning of this Earth. And by the way, the Earth, when it was created, there was no oxygen in the atmosphere like we have today. Human beings could not have survived on the Earth when it was created. So, as we think about this character, God, We don't know, we have to admit it's beyond our comprehension. And as we look at all this evidence that scientists are able to put together now, there's going to be people who disagree with it. They're going to say the Bible says something different. So one of the things, there's a fork in the road that we have to come to and ask ourselves, is it possible that there's an all-powerful God who's deceiving us with all the evidence that we are able to put together now? And we don't know. There's no way for us to answer that question. However, in the scenario in which there was an all-powerful God, which was trying to deceive us, then there really wouldn't be much point in trying to figure anything out. So I'm going to begin. At this fork in the road. I'm going to assume that the evidence, the scientific evidence that has been revealed in the universe that God created is not deceptive. Okay, I don't believe that in a deceptive God. I can't rule out that it's a possibility, but that's where we're going. So shortly after, life begins, and so I introduce a new character called Luca. Luca stands for the last universal common ancestor. So this is the first biological life. So you got this language, DNA. DNA is a very simple language with only there's only 4 letters in this language, and all the words are 3 letters long, meaning there's only 64 possible words in this entire language. And the variety comes from how you connect all the words together. So the very first life form, okay, according to biologists, that was able to replicate. So biological life definition is cellular and replication. So when all these pieces of DNA started attaching themselves together, they were instructions. So the first biological life was 3 million letters long and included the instructions for cell division, something scientists call nuclear fission. That's the beginning of life. So very early on in Earth's history, we have life, and shortly thereafter, maybe 1 billion or 2 billion years later, we have some cyanobacteria come into play that can photosynthesize water and carbon dioxide. So water and carbon dioxide were plentiful when the Earth was created, and these bacteria metabolized carbon dioxide, and I can make a little formula here to show you that. So what we had is we had lots of H2O and CO2 in the beginning. Okay, so that's what we began with. We began with an Earth that had a lot of these things. And these cyanobacteria created carbohydrates and oxygen. Okay, so they converted, so you can see the hydrogen from water went into carbon dioxide and into carbohydrates, and all right. So these single-celled bacteria created an oxygenated atmosphere. So if you talk to a lot of people today who are climate deniers, they say humans are not powerful enough to fundamentally change the atmosphere. Well, I got news for you. The atmosphere was fundamentally changed by single-cell bacteria. So if they can do it, so can we. So I don't want to spend too much time going through the Earth's history, so I want to fast forward if we can. Give me a second here. Through, toward the present day. So life begins, and then it becomes slightly more complex. And in the last 500 million years, we've had 5 mass extinctions. So what happens is you have dominant life forms arise, they die out, leaving an empty playing field for new life forms to arise. Mammals, who we came from, arose around 200 million years ago. And the last major extinction was 65 million years ago. And, our mammalian ancestors, most of them died out except for very small ones. Most of the large life forms on Earth died out, except maybe things like alligators and turtles, who are amphibious. So when this massive meteor, lands in Mexico and sends up a big cloud of dust, all the big animals die off except those who can hide in the ocean or in the water. So that brings us to, a level, a cleared out playing field in which our ancestors were able to emerge. So I'm going to I gotta. So one of the things we didn't talk about with DNA is, DNA, the process by which DNA changes over time is called mutation. So mutation is something we can see that today with COVID. We see new variants of the COVID virus coming up all the time as it's mutating. So mutation is the process by which we evolved. Now, a lot of people who are clinging to religious definitions that humans did not evolve from other creatures. And unless God is very sneaky and tricking us, that's not the case. So I've got a lot. I'm not keeping up here with the slides. So I'm actually going off the top of my head here. And so about 25 million years ago, I have a question for the audience. So humans are the most populous primates on Earth. Does anyone know what the second most populous primate is? Okay, so you don't know. So the second most populous primate is a monkey called it's a rhesus macaque, and our DNA split from these monkeys about 25 million years ago. And the reason I point out this particular species is it's a species of monkeys that lies to each other. So they have Machiavellian behavior, and the lying is particularly pronounced when it comes to mating. So they have alphas in their communities, and in order to ensure mating diversity, they mate with the alphas and then they sneak off and mate with others to ensure more diversity. So the reason I point this out is that Machiavellian behavior that humans demonstrate is not unique to humans. Machiavellian behavior is a survival advantage to other species. All right, so we move on so we share 93% of our DNA with these monkeys. As we move forward into history and into the future, 6 million years ago, we split from chimpanzees. We share 98% of our DNA with chimpanzees. So in the last 6 million years, we've evolved from chimpanzees to modern humans. And so what we've done, the primary mutations or changes is we now walk upright. We have opposable thumbs. We have a voice box, which enables us to speak, and we have bigger brains. Those are the primary differences between ourselves and chimpanzees. At the same time, life is changing on Earth. In the last several billion years, the planet itself has been changing configuration also. The landmass of the continents has come together and split apart, come together, split apart multiple times. So around 2.5 million years ago, we entered something called the Pleistocene epoch. That is the last significant change in the physical configuration of Earth. And that is when the Panama Isthmus slid into place between North and South America. Prior to 2.5 million years ago, the Atlantic and Pacific Ocean used to cross back and forth between North and South America. When this landmass came into place, that changed global ocean circulation. So for the last 2.5 million years, the planet has been relatively stable in terms of its physical configuration. And during the Pleistocene, the last 2.5 million years, the variations in the Earth's climate has been governed by Earth's orbital cycles. So I'm going to make a little chart here. Okay, so there's, okay, so we've been going back and forth between hot and cold in 100,000 year intervals. And that hot and cold, those intervals have been governed by the Earth's orbital relationship to the sun. As the Earth tilts to get more sunlight, it triggers more CO2 release. CO2 release triggers more warming. Warming triggers more CO2 release in a cycle until the Earth's orbit pivot switches and gets less sunlight. So we have, in the last 2.5 million years, for every 100,000 years, had a cycle in which Earth's carbon concentration has oscillated between 160 and 280 parts per million. At 160 parts per million, we have what's called a glacial maximum. Okay, a glacial maximum involves Boston being under ice. Okay, and at 280 parts per million, we have something called an interglacial, which is what we have right now. Okay, so this cycle has been, was not interfered with for 2.5 million years. So evolution continues. Finally, about 300,000 years ago, Homo sapiens arrives on the scene. And so if we've been around for 300,000 years, we've lived through 3 of these interglacial and glacial maximum cycles. So, during this time, humans are advancing. They're developing skills with tools. They're having competition. Around 70,000 years ago, there was a massive volcanic eruption, Toba, which is thousands of times more powerful than, say, Mount St. Helens. The human population is reduced to just a few thousand people. So if you can imagine, right now we have 8 billion people. So 75,000 years ago, for every person we had 75,000 years ago, we have 1 million people today. I don't know if you can appreciate a 1,000,000-fold increase in population. Like if you think $1 buys you a candy bar, $1 million buys you a luxury home. So the difference, well, okay. So after this happens in the next 20 or 30,000 years, the Neanderthals die out, the Denisovans die out. And then we bring ourselves to the most recent interglacial. And that this is called the Holocene. So I'll write that out for you. The Holocene is the last 11,700 years. Okay? So the Holocene really isn't any different from the previous 25 interglacials. The only difference is humans had enough advances with tools to take advantage of the interglacial weather conditions to begin agricultural civilization. So we're moving forward into the future, and I'm going to find my way into the notes here. All right, so we're at the Holocene. So once again, the Holocene, that was the weather conditions that were present 12,000 years ago at the beginning of human civilization were not fundamentally different from interglacials for the last 2.5 million years. And it's the third interglacial in human history. So we have tools, and now instead of hunter-gatherers, we have the ability to grow more food than we can eat in that moment. So excess food completely changes human history and social systems. So the first food, that was like the first currency, the first capital, and it paved the way for, bigger societies. So what you have now is, instead of 30 or 50 or 100 people working together as a hunter-gatherer pack, you have the potential to have populations that grow into the thousands and tens of thousands of people. And humans' biggest fear and enemy has always been other humans. So survival of the fittest meant that there was a lot of competition for agricultural land. And shortly after the beginning of the agricultural revolution, male DNA did something weird. 90% of the variety of male DNA disappeared in a few thousand years across the entire world at the same time. So what happened is there was wars, and when wars happened, the men on the surviving side killed the men on the losing side. So religion served a market of what would happen to us after we die. There became a marketplace for eternal life. So the people who controlled, societies were built around an idea of what happens to us after we die. People were willing to exchange cooperation while they were alive for what might happen to them after they die. And people who didn't, and because cohesiveness in a society was an advantage for survival against other tribes, people had an incentive to believe and go along with it. So if you were not along with the program, you might be killed as a heretic and kicked out. So we understand religion arises as part of evolution. It's not in conflict with evolution. Religion makes sense, as thread to hold a large group of people together. So I'm going to find my place here. So, what kind of, lots of institutions, terrible slavery began with the agricultural revolution. We developed a hierarchy. If 90% of the male DNA was eliminated, it didn't mean 90% of the males were eliminated. It just meant that 90% of them were no longer breeding. So people were slaves who might not have had breeding rights. We had currency and business and exchange. So this leads us to Christianity. Jesus was a real human being, and he was, in my opinion, a pretty noble character who was speaking truth to power. The way Jesus has been used is, the people who are wrapping themselves in Christianity are often using it for power. They're not living they're not living as Jesus lived. So technology became a big deal. Okay, so the printing press was invented, and that enabled information and language and learning to expand. Guns and ships were invented, and that led to imperialism. People got in their ships with their cannons and their rifles, and they went to places where there were indigenous people who didn't have the same kind of guns, and they were subjugated. And the people who were doing the subjugating told themselves a story that the people that they were subjugating, whether they're African Americans or indigenous Indians, were subhuman. They didn't have the benefit of DNA, and they used these stories to justify brutal imperialism. So, here we are in, we're in Utah, and there's a belief in the Mormon community here in Utah that American Indians came from the Middle East, where Jesus came from, and the DNA evidence says that's not the case. These people walked across the Bering Strait from Asia, so that so then we get to another, the discovery or invention that is getting close to climate change, is we discover the ability to turn fossil fuels into energy. So fossil fuel combustion is exactly the opposite of what cyanobacteria did on Earth in the beginning. So fossil fuels are taking the carbohydrates that cyanobacteria created in the presence of oxygen, and they're creating water and carbon dioxide. So this is fossil fuel combustion, exactly the opposite of. So now we get to a point where machines are starting to do the work of humans. Humans used to be doing all the work. And fossil fuels, this powerful energy, this concentrated energy of fossil fuels enables the advancement of human civilization. So, so let's fast forward to World War I. We have a big world war. So more technology also means more capacity to kill each other. So World War I results in 20 million people killed. And the Treaty of Versailles was between the winning powers of World War I, and the seeds of World War II were sown in the resolution of World War I. The results of Versailles were very punitive on the Germans, and they were starving to death. The indifference of the French and the English. The French and the English citizens thought Versailles was too lenient on the Germans. So we learned a terrible lesson. The Germans were starving. They were desperate. They went for Hitler and the Nazis. And that led to World War II, which resulted in 45 to 60 million people getting killed. So, I don't want to get into too much detail on World War I and World War II, but what I want to start to move toward is an understanding that the solution to World War II may be leading to World War III. So that's where we are now, okay? So we may be on the cusp of another world war as a result of environmental overshoot. So the solution to World War II, United States is the big winner. The war was not conducted on our soil. So the rest of the industrialized world is in tatters and needs to be rebuilt. And in the post-war period, the United States, despite having 4 to 5% of the world's population, has almost half of the world's GDP. So an American man in the aftermath of World War II could get a job in a factory where it can work for Ford or Chrysler, and they can afford a home, they can afford a stay-at-home mom, a stay-at-home wife, and 3 kids. That was, this was an unprecedented one-time advantage for Americans relative to the rest of the world. So a lot of people, it's popular to say, make America great again. And people have this fantasy that we could ever be that successful relative to the rest of the world. And that's not going to happen. So this generation of people who were born, so at the end of World War II, we had 140 million people in the United States. And in the next 18 years, this baby boom generation, 76 million new people. So I don't know if you've ever seen a nature show where a snake swallows something which is bigger than the aperture of the snake's body, like a pig. And you can see the pig moving through the snake's body. That's the way the boomer generation has moved through American history. Everything has orbited, the gravity of boomers as as an interest group has dominated American history ever since they showed up. When I'm a boomer. I came in at the end of the boom in 1962, but in the 1950s, under Eisenhower, we had 90% top tax rates. in the 60s, we had 70% top tax rates. So the public sector was richly funded. When I was a child, the University of California was free to state residents. When I went to college from 1980 to 1983, it only cost me $4,500 a year for tuition, room, board, housing, everything combined. So, and when I graduated in 1983 with an accounting degree, I had 5 job offers making $20,000 a year. So there was plenty. So 1 year's starting salary was enough to pay for 4 years of college. So that doesn't exist today. So things were really easy. Buying houses was easy for people in my generation. So when my generation got done with all of the wonderful, public funding that benefited us, we decided we didn't want to pay taxes anymore. So we elect Reagan, and he cuts taxes down. So Reagan wins in 1980, and then 1984 he wins 49 out of 50 states. So the Democratic Party responds to that. So from 1932 to 1968, the Democratic Party dominated. So what we had was effectively a Labor Party that served the common people under FDR, and the Republicans were a corporate party, that tended to big business. Well, Reagan comes along, he wins 49 states, and the Democrats say, well, we have to give boomers what they want if we want to win. So the Clintons come along and effectively take over the Democratic Party moves to adapt to what boomers want, and we wind up with 2 corporate parties. So what we lose the balance between what's the benefit of the common person and the benefit of wealthy people. So after boomers come along, we pivot to a situation where we don't have a balance, and both parties are serving the interests of rich people. So in terms of, carbon dioxide levels, all right, so everything is, all go for big business at this point. So in the last century, so I'm going to try to explain something. So earlier I showed you a chart, all right, that carbon dioxide levels oscillate between 160 and 280 parts per million. After World War II is over, things start going through the roof. So, and they're increasing faster and faster. So I got some numbers in here. All right, so at the end of World War II, in 1945, we're up to 310. All right, 310 parts per million. Since then, carbon dioxide levels last year went up to 430 or 428. And carbon dioxide is not the only greenhouse gas. If we include the impact of other greenhouse gases like methane, the carbon dioxide equivalent now is over 500. So So here we are. If here at 160, we have a glacial maximum, or Boston's under ice, and 280, we have an interglacial, what do we have at 500? We're farther away from the norm then the glacial maximum is in the opposite direction. Now, one of the things you need to understand is that the Earth doesn't respond immediately to an increase in carbon dioxide levels. If you boil water on a stove, when you change the heat setting, the water doesn't boil instantly. It takes time to react. So what we see today is, do you need to use the bathroom? Okay. So what we see today, right, in terms of the consequences of climate change is basically about 30 or 40 years delayed. So we are, the heat waves, the flooding, the wildfire, the stronger storms are a reflection of what carbon dioxide levels were maybe during the Clinton administration. So if we stopped emitting carbon dioxide today, then we'd still have another half a century of things getting warmer. So we don't know where that's going to take us. All right, so the increase in carbon dioxide, despite the fact, so in 1965, while Lyndon Johnson was president, there was a report given to President Johnson about the dangers of carbon dioxide. In the 1980s, Carl Sagan and James Hansen testified before Congress. So how have we responded to this as a species is not too good. In the 1960s, global CO2 levels rose by 9 parts per million. In the 2010s, the most recently completed decade, they went up by 24 parts per million. So as time is going on, despite all these warnings, carbon dioxide levels are increasing faster and faster. How are we doing on time? What time is it? I just want to... 7:15. Okay, so how much time do we have here? Okay, so this generation of boomers, they're in we are a nuclear power of the United States. We are functionally unaccountable to the rest of the world. We can't be attacked conventionally. We might be, there may be, people might want to plant a virus or put information in the news to try to tear us apart. So I'm going to move forward here. So, we got a problem. This CO2 increase is getting out of control, and at some point, we can cross tipping points or feedback effects where it can't be stopped. If we look at, the warmest planet, does anyone know what the warmest planet is? Venus. It's Venus. That's right. So Venus is not the planet which is closest to the sun. Venus is the second closest to the sun. So Mercury is 30 million miles from the sun. Venus is twice as far from the sun, but it's much hotter. The reason is that Venus's atmosphere is 95% carbon dioxide. So there is possibility, there are pathways where, we can start a runaway heating that we can't stop. So it's important for us to be humble. When I talk to my friends, a lot of them are, they have what I would call techno hubris. They believe anything can be solved with technology, that we can rebuild a world with the same resolution of 4 billion years of evolution with a computer. they fantasize about things like artificial photosynthesis to balance us out, and that doesn't exist. So, what I want to jump to here is, given that we don't have too much more time, is I want to talk about, one big thing that's on the horizon now. The consequences of climate change are so diverse that it's impossible to get our arms around them in a short period of time. That will be many episodes. But one thing which apparently is, scientists are saying there's a 59% risk that the Atlantic Ocean overturning circulation will stop by 2050. So they're saying the 90% confidence interval is between 2037 and 2064. So what does this mean? So I don't know if people understand that the ocean circulation moves like this, okay? If you just go to the beach and you look at the water, you can't see that the ocean is turning over like this. So what we have, the normal circulation takes warm water from the equator and it gives off heat as it travels north. So it warms places like Europe. And as warm salty water goes north, it becomes cold salty water. Cold salty water is the heaviest water. So when it gets north and it's given off all its heat, normally it sinks to the bottom of the ocean and it moves back south. So that's what keeps the ocean moving around. Well, we got a situation where there's enough fresh water coming out of the Arctic and melting off Greenland that in the place where the water sinks, instead of cold salty water, we have cold fresh water. And the cold fresh water isn't heavy enough to sink. This is like a clot in ocean circulation. So if you can imagine in human beings, if you get a clot that stops circulation, we call it a stroke. So we're on the cusp of giving the ocean a stroke. So what does that mean? So the overturning circulation brings oxygen, carbon dioxide, nutrients into the ocean. We're talking about deoxygenating the ocean. Okay, if we stop the ocean circulation, the ocean is like a vacuum. This circulation is like a vacuum cleaner pulling water off the East Coast. We can get an instant, relatively instantaneous, within a decade, 1 to 2 feet, 3 feet of sea level rise on the U.S. East Coast and Gulf Coast. The temperature in places like the United Kingdom, Scandinavia, Europe will decline by 5 to 15 degrees Celsius immediately. I don't know if any of you have seen the movie The Day After Tomorrow. That is a non-scientific representation of a circulation collapse. So, and the other thing is it would change global rain, patterns. So this is something that if it were to happen all by itself, it's apocalyptic. And so, my friends might say abstractly, oh, it'll kill 1 billion people, so we'll still have 7 billion. Well, there isn't a lot of precedent for an orderly reduction of population by 1 billion people. I mean, people don't roll over and die voluntarily. No one raises their hand and says, I'll be part of the population that will go away. This is a recipe for disorder. Another big thing that can happen is the glaciers, which provide fresh water to 1.5 billion to 2 billion people in Asia from the Himalaya and Hindu Kush mountains. Those glaciers are on the path to be gone by the end of the century. We're talking about billions of people who won't have fresh water. So we're on a path to really horrible circumstances. And so the question is, who is managing this? Who is responsible? Who has authority and jurisdiction over the carbon dioxide content of the atmosphere? And the answer is nobody. So, what we have is a lot of pretenders. So, in, let's see where I am here. So I'm at this point, I have a list of questions that I think we need to ask ourselves that are not being asked anywhere else. And that's what the need for this podcast is. So one is, who is responsible for global atmospheric CO2 levels? The answer is nobody. This critical resource that 8 billion people share, no one has the authority to regulate it. It is basically an open garbage pit. So, the next question I would ask is, what's the difference between the liberty to own slaves 200 years ago and the current liberty to add unlimited carbon dioxide to the atmosphere? So I'm going to say that, it's owning slavery is a much more graphic image, right? We can tell a picture. We can see pictures of people with whip marks on their back. And, it's something that, we've seen depicted. It's ugly, right? And so it's a visceral reaction. So adding unlimited CO2 to the atmosphere is not quite as personal. The carbon dioxide's invisible, but it's going to kill and harm more people. So we don't have any place in the United States or anywhere that I can really think of where there's a discussion about the liberty to continue adding more CO2. So what we need to do is have that conversation. If we proceed with this podcast, we're going to ask this question. So next question, should wealthy people be able to add as much CO2 to the atmosphere as they wish? Should wealth provide an entitlement to unlimited pollution? This is a hard thing. When I talk to my friends, right? I talk to my friend Jay, and I made my best friends a bet that we would have to stop global, international recreational aviation within a decade. I made this bet about a year ago. And their response is, rich people will never give it up. And that is exactly the same attitude that slaveholders had in the South 200 years ago. We're never going to give this up. So my response to them is, it will end. It must end. And the only question is proactive or reactive, is how ugly is it going to be, right? Before we recognize that we have to restrain ourselves. So another question is, right now, a Bitcoin transaction uses 1,000,000 times as much electricity as a standard debit or credit card transaction. Why do we have Bitcoin? Why do we need it? Is there any sane species which would add this to our portfolio of activities? It's just adding tremendous amounts of need for electricity and carbon dioxide to the atmosphere. Why are we doing it? Who is the person who's asking the question whether or not we should be doing this? And the people who are in the cryptocurrency industry, they're at the Democratic Party convention buying off politicians. But this is something insane, and we don't talk about it. So Here's another question. What is the ratio of US per capita emissions to what the global scientists are recommending, right? So if you're watching the news, the Democrats are bragging about the Inflation Reduction Act. Democrats are positioning themselves as the good guys on climate. Well, the answer to the question is that US per capita emissions are 6 times. So the global scientists are saying we need to get down to 20 gigatons per year, 20 billion tons of carbon dioxide emissions per year by 2030. If you divide that 20 billion by 8 billion people, that's 2.5 tons per person. So the United States now, we're at about 15 tons per person. 15 divided by 2.5 is 6. So while the Democrats are beating their chests about what a good job we're doing, we're still 6 times, we're nowhere near what the scientists are recommending. And who's telling that story? Nobody. So how much? So 15 tons is 30,000 pounds a year. That's like the weight of a house in this gas. So every day, I don't know if you've ever had to lift a 5-gallon water jug that goes into those water dispensers. 2 of those weighs 80 pounds. That's how much carbon dioxide every person puts into the atmosphere every day, the weight of 2 of those 5-gallon water jugs full of water. It's a lot. So, one of the things I want to talk about quickly is the posers. Who are there's a lot of people out there representing themselves as the good guys, okay? Barack Obama, as president, got the United States into the quote-unquote Paris Accords. Did the Paris Accords create any jurisdiction, any responsibility, any legal requirement? No, nothing. It was performative. Okay? Al Gore, okay, makes the movie Inconvenient Truth. Well, how does Al Gore get to all these international places like Davos or to lecture or to the annual climate conferences called COP? He's going there on a private jet. Al Gore has a massive carbon footprint. Leonardo DiCaprio, right? He's a guy who made the movie, was in the movie Don't Look Up. He's got a massive carbon footprint. So when he tweets out that the president of Brazil should not, encourage deforesting of the Amazon, the president of Brazil tweets back at him, go enjoy your private yacht. So what we have is we got a lot of rich people with massive carbon footprints who are hypocrites. They write the responses, so Citizens Climate Lobby is an organization of older Americans who, represent themselves as the good guys, but they're basically mouthpieces for the U.S. Congress, right? Bragging about how good the Inflation Reduction Act is. When I was in Wisconsin, I go to presentations at local Democratic Party meetings, and the guy there is bragging about the results of the Inflation Reduction Act. And when I ask this person questions, this is like a former professor, his presentation is fictitious. So climate scientists are basically blaming, the typical bad guy now is the fossil fuel companies. They're the drug dealers. They're the ones who provide fossil fuels. Who are the users? That's us. We're the people who are demanding fossil fuels. This apartment is, heated or cooled with fossil fuels. I use a car. So Um, just to let you know, like one trip overseas from the United States to Europe and back, that's more than the 2.5 tons that we have allotted per person for the whole year. That doesn't cover food or anything. So it's we're dealing with a situation where we don't have um, a lot of people are telling a story which doesn't add up. So I want to talk about solutions a bit, some of which are kind of radical. So um, one of the solutions is universal basic income. So um, we have an economy now which is based upon giving people what they desire. People want to go to Europe. They want, you know, perpetual. What's that? Something smell?
You smell something burning?
I don't smell anything burning.
I keep smelling it. I might be crazy. Go on.
Maybe it's my head from thinking. So if we look at our economy, how do you get rich in America? In a capitalist economy, you give people what they desire. So we live in a world and an economy that orbits around giving people what they desire. If you give people what they desire, you make a lot of money. That is the way our country works, is giving people what they desire. In the course of giving everyone what they desire, we're losing track of what we need. We need an atmosphere within a narrow range. If this atmosphere gets out of this range, and it may already be out of that range, then we're going to go extinct or have we're going to have a significant, we're going to have an apocalypse. So what we need to do is get back to what we need. We need to stop doing things that we don't need to do, or we're going to lose everything. So universal basic income is about giving everyone what they need. Food, shelter, medical care, education, broadband internet. If we have what it takes now to give everyone on this planet what they need right now, and then we need to stop doing a lot of things that we don't need to do anymore. We need to stop putting CO2 into the atmosphere recreationally. There's no need for recreation. If people want to go to Europe, let them take a boat instead of a plane. So, one of the things that is hard is, if we look at our country and our government. So it's important for United States citizens to demand that our government participate in a global agreement to limit carbon dioxide levels. Go ahead.
There's one piece of all this that I realized that we haven't even approached that comes to right what you just said. If we incentivize reducing the amount that we put out, technology is going to get better.
Technology?
Yes, the things that we use day to day that pump out CO2, it will be in monetary's interest to make those things produce less CO2. So it's not just using less, it's growing up, because we have the technology to make so many things more efficient, but there's no incentive to do it.
So what we need is a grown-up. So imagine it's like in your, in a typical family, right? you got parents and you got kids. And in a family, the parents are responsible for raising the kids and setting boundaries. So bedtime comes, 9 o'clock, 10 o'clock, whenever that time is, there's some adult to set a limit. Right now, we don't have an adult setting the limit. We don't have anyone who's responsible for this. So the path by, the technology we need is restraint. We don't need technology to get. Bitcoin is technology. It's destructive technology. We don't need technology to stop Bitcoin. We need intelligence. We need a grown-up.
Like, specifically what I mean, yes, 100% right. We need to do that way more than we need to improve technology. Way more. But think about it. If we stopped, if we made it less incentive to use non-renewable plastics, right? You could only use those for like the most important stuff, medical equipment crap, right? You can only use, right?
Mhm.
And then we will immediately stop polluting with so much.
Well, we
plastic.
have.
We use technology that is not pollution, right?
So one of the things. So you mentioned that's. So I am focusing primarily on one kind of pollution, which is carbon dioxide in the atmosphere. There's lots of different kinds of pollution.
Plastic is how much CO2 it takes to make plastic.
Right. So what we need to do things like, if you look at a package of Fritos, it's a plastic package with garbage food on the inside. It's poison on the inside, poison on the outside. We don't need Fritos. We should just stop it. So, one of the things that people are going to understand is like, oh my goodness, this is going to kill the economy. We're going to kill growth. It's going to kill the stock market. Yes, the future is going to. We can have a stock market for a little while, or we can survive as a species. We need to get rid of, stop doing all sorts of things which are not necessary, and put people to work restoring the planet and the environment. So how do we do that? Look at our political culture right now. We have a constitution that has us wired into a two-party system. There isn't. So what we need to do is take over. So one of the things I would recommend is political migration. So in order to change the Constitution, a constitutional amendment needs to be approved by 3/4 of the states. That means you need 38 out of 50 states. That's a tall order. So in order to get a filibuster-proof majority with one party in the Senate, you need 30 states instead of 38. That's realistic. So one of the things we can do is encourage people, young people who have a stake in the future, to move to places where their vote counts. So here we are in Utah. There is not any chance that Utah is going to be a blue state. It's going to be, so young people like yourselves might have to leave Utah and move to a swing state. And as you listen to that and think about it, you're like, shit, I don't want to move. That's a hassle. I want you to compare that to the things that people had to do in the Civil War or World War I or World War II. They had to go fight a war to the death. So what we're asking young people to, what I'm suggesting, I'm offering a path to young people is they can take over the politics in this country if they're willing to move to a place to make their votes count. So if somebody were coordinating and getting people to move to the states where they could take over 30, there's a path. What?
I mean, there's arguably an equally effective method of changing the political system, which is everyone should stop voting.
Stop?
No voting whatsoever. Do you know what? How are they going to fudge it and pretend that we're all on board with all this crap they're shoving down our throats if we all literally stop voting?
Okay,
And
so
that's
I am going to thank you for bringing that up. I don't think that's
we couldn't get
feasible. That
close
is,
enough to do it, but it is technically the more viable option. If
I
we wanted to
disagree.
change the entire political sphere, because
Okay.
we agree that the two-party system is garbage, and it's been sending us down the river
Right.
Styx for
Well,
far too
so,
long.
but the path to changing that system
Is to
needs,
reject it entirely, is it not?
no, I disagree. And we could talk about this some more. I'm
Okay.
glad that you, you know, that you're bringing this up, right? Because the power today is what it is. How do we change it? What's the path to get the leverage? You have to take over the system as it is and then get enough power to change it to what you want it to be. If you walk away and say, I'm not going to vote, then the people who are going to vote are the old people who like the status quo, and they're going to elect the government. So,
You have a point there.
all right. So if we take over, you know, if 30 out of 50 states go, or say they become under the control of Gen Z and millennials, then you can expand the Supreme Court. And instantly, you know, right now we got a 6-3 majority. If you make the Supreme Court 15 people and you add 6 new, you know, left-leaning justices, then you flip the power. So what else can we do? In 1942, okay, you talk about technology. In 1942, we rationed as part of the World War II effort. We had a big, you know, we declared an emergency. We had to beat the Nazis and the Japanese who attacked us at Pearl Harbor. So everyone came together in a socialist effort. We restricted, we rationed gas, butter, coffee, you know, all kinds of things in the service of something bigger. What we need to do is we don't need new technology. The same kind of legislation, we need to ration CO2 emissions. And we need to set a ceiling and have an agreement around the whole world. So no more yachts, no more private jets. You know, so another thing we could do is we can change the name of climate change. So I'm going to use an analogy here. Imagine you have a friend who drinks a liter of whiskey and has to be rushed to the emergency room. And you get a phone call from the hospital to come, you know, because your friend needs someone to advocate for them. So you get to the hospital. Does the nurse or the doctor that talks to you, do they tell you that your friend has body change? If they did, you'd be like, what the hell are you talking about? Body change. What a doctor would tell you is that your friend has blood alcohol poisoning. So blood is the location of the poison. Alcohol is the name of the poison, and the word poisoning is an unequivocal declaration of toxicity. Why do scientists use this term climate change? You know, they all know that it means atmospheric carbon poisoning.
It's pandering.
Right? They're bought off, right? So one of the things we do is we need to start calling this what it is. This is atmospheric poisoning. So what else can we do? We can form a government in waiting. Okay? Right now, your generation, Gen Z, millennials, you don't have someone, you're 100 million people. Who speaks for your generation? You know, you guys need a generational leader. You know, slavery, okay, had Abraham Lincoln as the focal person to end slavery in America. In the Indians gained independence with Gandhi as a figurehead to organize and coordinate everyone. You know, the civil rights movement had Martin Luther King Jr. organizing a 1,000,000-man march. They had a leader. So young people need to get together and say, we're 100 million, you know, there's 100 million Gen Z and millennial, you know, people here. Let's get someone who speaks for these 100 million people and demand on behalf of 100 million people instead of being diluted and divided and conquered. So what I would suggest is we create a competition and get someone from your generation to lead this fight. We can cancel student debt. We can remove tax breaks for people who are buying residential real estate. Your generation has a huge problem affording housing. Do we want to create a plutocracy where residential housing is owned by a few people and we all become rent slaves? These are policies that are going to help young people. I guess, if we have UBI in which housing is included, then we're fine. And, strategic migration, one of the states that young people should leave, for example, besides Utah, is a place like Florida. I mean, Florida is destined to go underwater. Okay. I mean, the real estate market is beginning to collapse. In 2021, the Champlain Towers went down, and suddenly people realized that all these condos, the maintenance budgets were not being attended to. And now we get more hurricanes coming in, more damages, insurance is going through the roof. We have a bubble. We have a big climate bubble popping. So getting young people to move away from places which are destined to be destroyed is just intelligent working together. I think we should ban people from holding public office who adhere to a belief that the earth is a disposable depot. So we're talking about rapturists.
Yeah, I was gonna say people who think that the earth is
right.
Just gonna
I have to. So you might think on the surface that anti-extinction is nobody wants extinction to happen. It's not true. There are some religious people whose belief system is that we need to destroy life on earth in order to get to heaven. We should demand that people who hold office in the United States sign an oath that they are not committed to ending life on earth. This is the contrast we need in our politics. So instead of contrast on other issues like identity politics, so earlier I'm getting close to the end here. So earlier I talked about a character called God. I'm going to talk about another character that I would characterize as a devil. Now, I don't believe in an actual character who is a devil. I don't believe in a devil, but I do sometimes imagine what a devil would do. So imagine that there was a devil who wanted us to go extinct. Well, that devil would get us to focus on other problems beside the things that are causing us to go extinct. So, and this is controversial and difficult. So, you know, if we look at the news, you can see focus on gender issues. We can see focus on racial issues. Um, and I'm not saying, these are obviously very painful problems, but extinction is going to hurt more women. It's going to hurt more Black people um, than anything that's specifically targeted at those groups. So what you know what I this the devil is dividing and conquering us. This is an issue that affects everyone. And so, we need unity. If it were up to me, I would make what Rachel Maddow and Sean Hannity do illegal, right? I would, but they are both serve a purpose of dividing us from each other. They cater to an addiction, for us, to our egos and our sense of virtue, that we're better than someone else.
Their whole purpose is to muddy the waters of the argument.
Is to what?
Muddy the waters of the
To muddy the waters. So I would say I would make, things like that illegal. So this is a lot for one day. I realize, I think this conversation is going to be better with multiple people having a microphone with someone else, and we need to, hash this out. I appreciate, I think if you had a camera and a microphone on you, then we would be better off. So I'm ready to kind of bring this to closure and just have a conversation. If you want to stop now, Michael, I think we're good, and I'd like to just chat. And peace.